Hi everyone! Today we are going to learn about nucleophiles and electrophiles. Watch till the end of the video for some practice questions. Nucleophiles are electron pair donors or Lewis base. They are electron-rich species that tend to seek an electron-deficient site for a reaction. In order to be a nucleophile, they must possess lone pairs of electrons. Examples of nucleophiles include anions, or molecules with lone pairs of electrons. Carbon atom is also electron-rich when it is involved in double or triple bond formation with another carbon atom. So C double bond C and C triple bond C are nucleophiles. Benzene ring is another example of nucleophile. Electrophiles are electron pair acceptors or electron-deficient species. In order to accept electrons, they must possess an empty orbital to receive the electron pairs, and therefore they are also known as Lewis acids. Examples of nucleophiles include cations or free radicals, electron-deficient centers that are found in polar covalent bond, such as in carbonyl group, ketone, or aldehyde. A good electrophile must be able to accommodate a new sigma bond between its electrophilic center and the nucleophile. When drawing the reaction mechanisms, curved arrows are used to show the movement of electron pairs. The arrow always originates from the electron pair donor, or the nucleophile, to the electron pair acceptor, or the electrophile. Let's do some practice questions. Since ketone has both delta positive and delta negative atoms, can it act as both a nucleophile and an electrophile? Pause the video to think about it. Pi bonds are very polarizable. So molecules with C double bond O bonds have very delta positive carbon. Thus carbonyl carbons act as an electrophile. A nucleophile readily attacks the delta positive carbon and donates an electron pair, and the pi bond breaks, transferring an electron pair to the oxygen. So yes, the carbonyl carbon acts as an electrophile and is prone to attacks by nucleophiles. Now, does carbonyl also act as a nucleophile? Because oxygen has lone pairs, it potentially can donate an electron pair when attacking a positive ion. Therefore, the carbonyl oxygen can act as a nucleophile and attack an electrophile. In conclusion, carbonyl can act as both an electrophile and a nucleophile. What about water? Can it act as both a nucleophile and an electrophile? The oxygen on water has a partial negative charge, and it readily donates an electron pair to an electrophile, just like in this example. The lone pair of electron on oxygen attacks the delta positive carbon while X leaves. So in this example, the oxygen on water acts as a nucleophile and attacks the electrophilic carbon. Now, water is amphiprotic, and a small amount of it undergoes auto-ionization to produce hydronium and hydroxide ion. Hydronium ion is a very weak acid because it can act as a proton donor. Hydrogen ion has a positive charge and can accept a lone pair. Thus, water can also act as an electrophile. In conclusion, water can act as both electrophile and nucleophile, but the nucleophilic character of water is stronger than the electrophilic character due to the ready availability of lone pair of electrons on oxygen atom. Next, Is cyanide ion a nucleophile or an electrophile? Because there is a full negative charge on carbon as well as a lone pair of electrons on it, cyanide ion is a good nucleophile. It is strongly attracted to a region of positive charge in another species and donates an electron pair. Is chloromethane a nucleophile or an electrophile? Chlorine is very electronegative and it pulls on the bonding pair of electrons closer to itself, making carbon delta positive. In addition, chlorine is a relatively large molecule and is a good leaving group, as the CCl bond is quite weak. When chlorine leaves, it would give carbon a positive charge. These factors make the carbon in chloromethane an electrophile because it has a prominent delta positive charge. Since it's partially positive, it is electron loving. The better the leaving group, the better an electrophile the carbon atom attached to it. Is methanol a nucleophile or an electrophile? Hydroxy group is not a good leaving group as the larger halogens like chlorine or bromine. This makes the carbon in methanol a weaker electrophile than the carbon in chloromethane. On the other hand, oxygen has lone pairs of electrons and they are available to donate to an electrophile, just like in this example. However, because the oxygen on methanol only carries a partial negative charge, it acts as a weak nucleophile. That's it for today. Leave a comment if you have any questions. Thank you for watching.